Hello, Assalamualaikum. We meet again in this video. So as well, my name is Muhammad Akmal bin Kamaruddin. My matrix number 15DEM 19F1047. For today's video, I want to make a explanation about chapter telemetry for my case study 3. So stay tuned for the explanation about the telemetry. So now I'll be answering for the first question, which is the principle of telemetry. For the principle of telemetry means the transmission data for monitoring and control over long distance. Data can be sent directly as DC voltage or current up to a few meters at long distance. Speeds is severely limited and noise becomes a serious problem. The original most transatlantic cable of 19th century used DC which transmitted as less than 1 word per minute. So we move on to the second question, which is I'll be listing 5 elements of analog data execution with their explanation of each items. So for number 1 is transducer. Transducer is device that translating physical parameter into electrical signal. Number 2 is signal conditioner. Signal conditioner is amplifying, modifying or selecting certain portion of the signal. Number 3 is visual display device. This visual display device continuous monitoring of the input signal. This device may include single channel or multi-channel oscilloscope, storage oscilloscope, panel meter, numerical display and others. Number 4 is graphic recording instrument. This graphic recording instrument obtaining permanent record of the input data. These instruments include stylus, ink recorder to provide continuous record on paper chart. Optical recording systems such as mirror, galvanometers, recorder and ultraviolet recorders. And lastly, for number 5, magnetic tape instrumentation. Acquiring input data, preserving their original electrical form and reproducing them at a later date for more detailed analysis. So for the question number 3, I will listing 3 elements that will affect the auxiliary equipment and system programmer of digital data execution and explain the function of each of them. So for the 3 elements that will affect auxiliary equipment and system programmer is number 1 is scanner or multiplexer. Scanner or multiplexer, this device accepts multiple analog inputs and sequentially connects them to one measuring instrument. And number 2 is signal converter. Signal converter is function as translates the analog signal to a form acceptable by the analog to digital converter. An amplifier for amplifying low level voltage generates by thermocouples or strain gauge. And number 3 is analog to digital AD converter. This analog to digital AD converter converts the analog voltage to its equivalent digital form. The output, the AD converter may be displayed visually and also available as voltage output in discrete step for further processing or recording on a digital recorder. And for the question number 4, I will explain about the concept of multiplexer and demultiplexer. For the multiplexer is a circuit used to select and route any one of several input signal to a signal output. And simple example of a non-electronic circuit of a multiplexer is a single pole multi-position switch. Multi-position switch are widely used in many electronic circuits. However, the circuit that operate at high speed require the multiplexer to be automatically selected. A mechanical switch cannot perform this task satisfactorily. Therefore, multiplexers used to perform high-speed switching are constructed of electronic components. Multiplexer handle two types of data is analog and digital. For analog application, multiplexer are built relays and transistor switches. For digital application, they are built from standard logic gates. And for the demultiplexer, also known as demux or data distributor, is a circuit which can distribute or deliver multiple output from a single input. It can perform as single input many output switch. The output lines of demultiplexer are n in number. Select line number is m and n equal to 2m. The control signal select input code decides the output line which the input has to be transmitted. The demux can also perform as a binary to the decimal decoder. For this, the data input line should be logic at one level and the binary input is given to the select input lines. The corresponding line will give the output in the designing of multiple combinational circuit. This circuit is really useful. For the last question, which is question number 5, I will discuss about the characteristic for the frequency division multiplexing and time division multiplexing, TDMs. For the frequency division multiplexing, FDM, frequency division multiplexing is based on the idea that a number of signals can share the bandwidth of common communication channel. The multiple signals to be transmitted over this channel are used to modulate a separate carrier. Each carrier is on different frequency. The modulated carriers are then added together to form a complex signal that is transmitted over the signal channels. Each signal to be transmitted fits a modulated circuit. The carrier for each modulation FC is on different frequency. The carrier frequency are usually equally spaced from one another over a specific frequency range. Each input is signal given a portion bandwidth. The result is illustrated in portion of bandwidth. For the time division multiplexing is in FDM, multiple signals are transmitted over a single channel by sharing the channel bandwidth. This is done by allocating each signal a portion of a spectrum within the bandwidth. In TDM, each signal can occupy the entire bandwidth of the channel. However, each signal is transmitted for only a brief period of times. In other words, the multiple signal take turns transmitting over the single channel. This concept is illustrated graphically in figure that I will show later on. Here, for 4 signals transmitted over a single channel, each signal is allowed to use the channel for fixed period of time, one after another. Once all the signals have been transmitted, the cycle repeats again and again. So that's all in my videos. Thank you so much for watching.